Hey folks, in this video I want to talk about how to make your ADTs safe and keep them safe. So the first major topic for us is immutability. So immutability we talked about a little bit before. The basic idea is this. I want to have a class and I want to prohibit people from changing the contents of it. I want to basically etch it in stone. The hope is, right, that if I do this, I can all of a sudden pass it around my system and no longer have to worry about somebody changing something behind my back, right? This would be a very nice thing to do. Remember that my alternative is doing something like a clone, and a clone has to create an entirely new object. It's an expensive operation. Here, right, we just want to make one object that cannot be changed. So, what do? We have over here basically an example in the point2D class. So there's two things, there's two things you must do, right, and then another thing to keep in mind, right, if you want to make something immutable. The first thing, right, is that when you make something immutable, you're going to start by making all the variables inside of it final, so that nobody can change them, right? I can't change them as a class. Nobody outside the class can change them either. They're locked in forever, right? This is the first thing. The second thing, right, is to only provide accessors. So classes generally have two types of methods on them. One is mutators. The other is an accessor, right? So an accessor is something like this X variable, where it just looks inside, it doesn't change the contents of the object. A mutator would be something like setX, and that we don't want to have, because all of a sudden we're changing our object, it's no longer immutable. So we're going to make sure we have nothing that mutates state, we just have things that read out data. Okay, that would be our other thing. All right, so that's really all you need, right? Those two things are what we need to do in order to make something immutable. Now the unfortunate bit is that sometimes things aren't as straightforward as we want. So here, let's try an example here of just adding some code in. So let's say we had, we'll go private final counter C1. And you can imagine C1 gets assigned to a new counter over here in the constructor. Something like that. Right, we can imagine that for a second. Now, this is just a little bit, problematic. Now, what we see when we first look at this is we see, oh, this thing is going to work fine because I've made it final. Okay, you've made it final. Does that mean the counter will never change? Well, you know, for X and Y, I mean, yeah, it does, right? If I were to go right now, let's say I was adding some more code here. If I did something like X++, I will get a nice error from my compiler telling me that this is bad, right? You're trying to change something that you've marked as final. That's not all right, right? I will not let you compile because this is an error. Okay, perfect. But what happens if I do the following? C1.increment. So actually, why don't you think to yourself, what will happen? Will it compile or won't it, right? What will be the result? Take 1 second and think about that. Okay, so in this case, it'll compile, and it will change the value inside of increment. Okay, and this is, this is bad, okay? Because when we use the keyword final, what we're doing is we're locking in place the address that C1 stores. So I'm not going to be able to do things like this, right? I can't do C1 equal and then do a brand new counter, right? That is what final will prevent, right? Because it's basically saying, make this variable final, but the thing in that variable is just the address. So I'll never be allowed to change that address, but the stuff that stored the address, that can be changed, okay? And even, I can even imagine it worse, right, as I have something like over here, I have a new method called, return type, counter, right, called C, right, and maybe it just returns C1. If I have something like that, well, all of a sudden I'm going to be giving people outside a reference to this counter, right, and then everybody can click it as much as they want. This is bad, okay? So in general, right, we basically need to make sure that we don't contain anything, right, that is also changeable. Then we have problems, right? There's actually a couple things here that are an issue. First of all, right, so if we take in a reference type, right, and that's actually where the issue is coming from, because these are reference types, right? If we take in a reference type, right, as an argument for our constructor, probably what we want to do is do like a clone on it or something like that, right? We want to make it our very own, because if we don't, then somebody else outside might still have a reference to it, and they'll be able to change it, right? So if I take in any reference types, I want to, make my own version of that, right? Otherwise, somebody outside might still be holding on to a reference. The other thing, right, is basically if we do stuff like this, right, where we create a new counter inside, we're going to have to be very careful that we don't call this stuff, right? Because technically we could, right? Counter itself, right, isn't an immutable class. We could make one, right? It wouldn't be very useful, but we could make one. Actually, we could make one, and it would be useful. But we would actually, then that's what we should do, right? We should basically create a new counter class, right, that is immutable, right? Because if my immutable class, right, does rely on mutable classes, then it'll become mutable as well, right? So it has to be, immutable throughout in order to be a success. All right. So those are kind of our current issues here, right? We have to be careful with those reference types. Otherwise, right, it really just is make the things final, don't have any mutators. All right, so that's kind of an overview of how we make something immutable. The second thing I want to talk about, and this is going to be just really brief, is going to be exceptions. So exceptions. So what do we do with exceptions? First of all, we have our main rule here is we don't want to generate an ADT with bad state. So whenever I have an ADT in my program and it's just there and I can do stuff with it, it should have good state. I shouldn't ever have a stack with a null with a stack with a null error because there's no list inside of it, right? I shouldn't ever have a counter that has null for the name, right? I don't ever want to have an ADT with some sort of bad state. Anytime I have something, it should be good state. If there is an issue, I want to throw an exception, right? Rather than let that bad ADT be created and go around the system. The problem is that sometimes I'll create an ADT, like for example, point2d, and you can imagine you create point2d that maybe has some sort of bad state inside of it. Well, all of a sudden it's like you create it somewhere, pass it off, goes around your system, and all of a sudden it starts breaking things, right? Other people are assuming this works, right? They're getting its input as an argument or something like that, and all of a sudden it's bad data, it causes them to crash. And it can become hard to track down those issues because they're not really localized. So we'll just throw an exception, prevent it from ever creating something with bad state. You can see the example here for point2d, and here, right, we're basically just looking at the constructor, and we've added two little parts of code, right? Because we want to basically verify that we are being constructed with a valid number. So first thing we check against is it infinite, right? Because sometimes, right, you do some weird math, you get an infinite value. That doesn't really make sense. It's not a real point. You can't have an infinite point on a plane. It wouldn't make sense for us. So if it is, we'll throw an exception, right? Say we have invalid arguments, right? We'll give the user a nice error to let them know that it must be finite. They'll do a little bit more protection here, right? We'll check for an NaN, right? So not a number, because sometimes, right, you do some strange math, right? And it gives us back some result that's not a number. So again, we don't want to create anything that has, not a number in it. So yeah. This is roughly what it looks like, right? So the idea, right, is that whenever we create an ADT, right, when we look at the constructor, right, and the constructor takes some stuff in, verify that what it takes in is good data, right? If there's any sort of issue with it, throw an exception, let the outside know so the outside can actually fix it, right? Rather than creating a bad ADT, right, that goes around the system and then breaks something later on. Fix it up front. Depending on what you contain, right, it'll be different things you need to check, right? So here we were looking at numbers, we checked infinite, we checked NaN. If we had other types, right, reference types that came in as a parameter, probably we check for like a null pointer exception. Right? We check for, is this thing null when it really should have a value in it, right? Whatever is appropriate, we should check it. All right, so that about does it for our safety discussion. Again, we've kind of talked about how do we implement an immutable class, and then some rules for how we should treat exceptions in our ADTs.